My name is Jettro Coenradie. I work for Luminous. I do a lot of Elasticsearch consultancy, so that's why I'm going to give a presentation about making your Elasticsearch cluster perform. The things in the presentation are partly coming from my own experience and partly from documentation and presentations I attended from Elasticsearch. And well, let's see where we can get. There's a lot of theory to cover, so I will keep the questions to the end if you don't mind. If there's really something that you feel like you're missing out, then just shout out and then I'll try to very quickly touch it to help you out to stay in touch. Okay, so why would you use Elasticsearch? There's a few things, one of them being full text search. So if you have a website and you want to enable search on the website, you could use Elasticsearch. This is an example from the website of Elasticsearch themselves. Nowadays they have luckily a good search themselves on the website as well with some interesting features. Another one that a lot of people come to for Elasticsearch for is log. They stuff a lot of logs into Elasticsearch to be analyzed, and of course a lot of them come for this cool Kibana dashboards. I think most of us come for the cool Kibana dashboards, or not. So who came for the dashboards? Nobody? Oh wow, full text search, anyone? Ah, okay, cool. Now that's good because I don't have a lot of Kibana slides and I have a lot about full text search, so that's good. Okay, so when you start out with Elasticsearch, what usually happens, you go to the website, you download the tar file or the zip file, unzip it, open a command prompt, step into it, run bin Elasticsearch, and then you do a curl request. So if you do this curl request, it will check whether your cluster or your node is running, and it will give you this response. Anyone knows what this is? This is a random Marvel character that you get if you do it out of the box, and the cluster name will be Elasticsearch. Second step, you have a node running, you can insert a document. In this case, I insert a document to the index called conferences of the type conference with ID 1 and two fields in there, a name and a location. Well, that's easy. So now you have your cluster running, you have an index in there, and you have created a document in there. So you're done. Ready for production? Well, maybe not. So if you want to go into production, there's a lot of things, of course, you have to think about and you have to make choices for. These are the subjects that I want to touch today, because it's just like 35-40 minutes. I cannot touch them very deeply, but at least I want to give you an idea of where you need to change things and what you can do and where you need to think about. So we touch the cluster installation configuration, we go to the index and the mapping, and then we touch indexing, querying, analytics, and some tips there to get a better performance. And to check whether your cluster is running, we go a little bit into monitoring and to logging. So let's begin with the cluster. Some questions I get asked a lot is, well, how to install configure to do it right. How many nodes do I have? But how many nodes do I need for my cluster? This is probably question number 2 that I get asked. How many nodes? And then what kind of hardware do you need? Of course, these are very hard questions, but let's try to at least give a few guidelines. For the installation, you could do what I showed before, download the zip file, but for production, I would do it a little bit different. You could use a package manager. If you're running on Linux, you could use yum or opt, which is fine. It works. If you have multiple nodes, it might be better to think about some configuration management tool, use Ansible, Chef, or Puppet. These are all provided by Elasticsearch themselves, so check them out depending on what your favorite is. I personally like the Ansible ones a lot, but yeah, I mean, it's your choice. So the configuration, there's 2 important files. We have the first one, defaults Elasticsearch. This one is for the process that runs Elasticsearch. And the second one, the Elasticsearch YAML file, is actually more for configuring the node itself. So what should you do in it? The first file, there's actually one property that's really important to change, and this is the AS heap size property. If you don't change this file, by default you will get 265 MB. Which could increase to 1 gigabyte, which is not a lot, but it's also better to change for Java the minimum and the maximum amount of memory that you will use and use one number for it. So in this case, I set it to be 2 gigabyte. How much you would need depends, of course, a lot on the needs that you have for your node. Do not go over 30 gigabytes because then the JVM does some strange things with garbage collections and pointers and stuff. So it's advisable not to go over that. Then the second file, the elasticsearch.yaml file, what would you change there? Well, I would at least give the cluster a name, because it sounds so stupid to just keep it like running in Elasticsearch. And if you have multiple clusters at a certain moment, then we would definitely want to give it a separate name. And also give your node a name. Because if you don't name your node, every time your node starts up, it will get a different name. So if you have a problem with a certain node, it's hard to trace which one is actually giving the problem. So I would definitely give it a name with maybe the last digit of the IP address that you give it, or the name of the node, that you at least make it explicit, and that you know that if there is a problem with one of the nodes, that you immediately know which node to turn to. Then the second part in this configuration file that you most likely need to change is the unicast. Nowadays the default is unicast. You have two mechanisms. You have multicast, which does sort of auto-discovery, and you have the unicast where you have to explicitly tell what other nodes are available. The unicast is now the default. So if you have a cluster of, for instance, 3 nodes, then at least name them all 3 in here, that you know that which nodes they need to connect to. And the second option is the minimum master nodes. If you would leave the default here, then it would be 1, which is not optimal if you have a 3-node cluster and you wouldn't configure a minimum amount of master nodes, and one node would actually fall out because there's a network latency problem or whatever. Then it could be that you have a split brain and that they both would form their own cluster, and then they would try to get back together again. So always configure like the majority of servers. So if you have 3, configure 2. If you have 5, configure 3 minimum master nodes. And the last part, this is not default, but these are 2 properties I use quite regularly. The path repo is the location where the snapshotting, if you use snapshots of your database, of your Elasticsearch indexes, where it would store the snapshots. And there is no default location for this, so you have to specify it if you want to use it. And the last line is the script inline. Be careful with this, but if you know what you're doing and if you've secured your cluster well, then you can enable Groovy scripts. And you could do them inline, you can do them in a file, there's a lot of stuff that you can do. Sometimes I use this, so just for you to know that you can do it. Well, then the hard question, how many nodes do I need? So how often have people asked you this, or did you ask this? Someone, I mean, how many people here actually install Elasticsearch? Okay, well that's quite a lot. So you must have asked yourself this question, or people ask you this question. How many nodes do I need? 1, 3, 5, 27, 100? Well, I can't give you the answer. Sorry. It's so depending on so many things. But there is a few things that you need to think about when deciding upon the amount of nodes that you would need. Sometimes 1 is enough. In development, it's fine. But also in some production environments where it's not a critical environment, for instance, or it's very easy to get the data from somewhere and recreate it in an index. And if there's not a lot of queries, not a lot of people using it, then 1 node could be enough. But often, when it is becoming critical and you want it to be available, then you would like to have more nodes. So then you would turn to 3 nodes. The advantage of 3 nodes is 1 node dies out, then the others keep running, and your cluster could still run fine. You can have multiple shards, you can have replicas, and so your cluster is a bit smooth and ready for some annoyances. But then you're getting big, and now you really want to be flying, and you want to be ready for even more machines and more indexes. Then there comes another question, that is that you have different types of node that you can specify. The default is that every node can do everything. It can contain data, it can become the master node, it can be used as a client. But if your cluster increases and you have more data in there, you most likely want to have dedicated nodes that can become the master node. Because if the master node fails, then a lot has to happen to the cluster. It has to do elections for a new master node, and that could take time. It could mean unavailability of your cluster. So you want to almost make sure that that doesn't happen. Well, the biggest reason for a cluster to go down is out of memory. So if you do queries on the data, then an out-of-memory exception is more likely to occur. So the master nodes don't have data. Then you know for sure that that would not be the reason for a master node to go down. And then there are specific client nodes that you can use for your application to connect to. They also would not have the data, but then you can allocate all the memory on that node to, for instance, collect data and do the queries together and send it back to clients. So there's a good reason to separate these functionalities, these responsibilities. What hardware do I need? Well, this is maybe even more complicated, but there are some things that are good to know. It's better to have more cores than to have very high-end cores. So if you can choose between 2 cores or 4 cores with a little bit lower CPU speed, or 1 or 2 cores with a very high CPU speed, choose for the more cores, because there's a lot of parallelism in Elasticsearch. So it's better if you have a lot of thread pools to have multiple cores that can do the work for you. The memory, it should be somewhere between 8 and 65, although 64. I also have a lot of machines with just 4 because it's enough. So there's only one way to really do this, and that it's just to index your data and to test it. But this is a guideline. Don't go overboard. You could do more than 64, but the general guideline is like specify 50% of your memory and give it to Elastic, and keep the others for the OS, because your operating system also needs a lot of memory. And the more memory your OS has for Elasticsearch, the more files it can load into its cache, which is very good for the performance of your cluster as well. And if you have the choice, choose SSDs. Try to stay away from virtualized disks, NAT solutions or SANs or whatever. If you have the possibility, always use SSDs. Okay, so now you have your cluster running. You know sort of the amount of nodes that you would need, or at least how you want to find out how many nodes you need. Then we come into the next one, and it's designing your indexes. And this is probably question number 1. So the amount of nodes is question number 2, and question number 1 is how many shards. Because it's always shards. I will go into a little bit more depth what a shard is. But if you're coming more in this area, then know for sure this is the question that people are going to ask you, or that you want to ask to someone. And the amount of replicas is another one, and whether you are using time-based indexes and what that means to you. So what does an index look like? Just to give you a bit of a heads up, an index in Elasticsearch can contain multiple shards. So a shard could live in the same node, but it could also live in another node. And a shard is a way to be able to capture more data into your index. So if you have a lot of documents, then by giving more shards, you can just use more data. It's also a thing for speed. If you want indexing speed, you need more shards, because in more shards, more cores can write at the same time to your shards, and you know that you can index more documents. But underneath the shard, in the end, is a Lucene segment. Oh, sorry, a Lucene index. There's a Lucene library underneath, and Lucene uses segments, and segments are static files, so they cannot change. The moment you write a segment, it's fixed. This is important for the caching that I mentioned before. Your OS can load these files, can keep them in cache, because it knows that it's not going to change. So what happens if you want to change the document? Then it's going to be a new segment, and the old segments are in the end being thrown away. There's more shards in this picture. We have the P1 and the P2, which are the primary shards, and the R1 and the R2, which are the replica shards. So in this case, I have an index with 2 shards and 1 replica for each. But they all are the same Lucene indexes underneath. So how many shards do I need? Well, it depends a lot on the amount of documents. So if you have not too many documents, choose 1 shard. It's fine. I mean, in a lot of occasions, 1 shard is fine enough. If you, well, like I mentioned, if you need more performance, higher indexing speed, then you need more shards. But don't go overboard. The amount of documents in a shard, if it's too little, then you can have strange effects in the scoring mechanisms that Elasticsearch uses, because the scores are in the end calculated per shard, and if you have very wrong balanced shards, then the scoring could go really overboard, and you can get very strange results back if you have queries. Well, this is one of those guidelines. I haven't tried it out myself, but this is one of them coming from Elastic support, that you should try not to make the shards bigger than 50 gigabytes. It's one of those numbers that they figured out that is most optimal for your shards. Why would you not use an incredible amount of shards? Because there's one annoying thing in the amount of shards, and that is you have to choose it when you create an index. So the moment you created your index, you cannot change the amount of shards. Well, this has to do with the way routing works over the shards in Elasticsearch, but it would be easy to say, well, then I just take 100, because then I'm safe. but that is a lot of overhead. It would mean that you have to go to 100 shards for every query, collect all the results, and then create a response out of all these shards. So it's not wise to take too many. So my advice would be start small and test. I mean, one is maybe a bit awkward. Maybe you should start with 2 or 3, depending on the amount of nodes that you have. But on the other hand, why not? If 1 is enough, then 1 is enough. And then you can, with 1 replica, for instance, you can make sure that you won't, if some problem is there, that you will at least be able to switch between nodes. So how many replicas do I need? Oh, that was a little bit too fast. Well, that's also, it depends a lot on the amount of queries that you want to do. There's 2 functionalities for replicas. One is for resilience, so you get a copy of your data on another node, because a replica is never placed on the same node as your primary shard. Or it's for query speed, because now if it's on another node, you can send the same or different queries to 2 nodes, and you can double the speed for the query. So that's an optimization as well. Well, and then there's a question, should I use types? I think in the beginning of Elastic there was types were used a lot in the index. So you have in one index you can have multiple types, and then each type can have completely different fields. Well, not really completely different. Don't use one field with the same name and a different type in different. Well, now it becomes complicated. I think that's the reason why they don't want you to use types anymore, because it's so hard to explain. So from now on, in Elastic 2, try not to use types too much. There is some very rare situations where you do need to use them, but as a general rule of thumb, if you need a type, maybe to separate certain documents, use your own field, or just use multiple indexes. Another term that you hear a lot is aliases. This is one that you definitely want to use. So in your application, always talk to an alias. An alias is actually a pointer to an index, but you can do quite a lot more. You can also point it to multiple indexes. And you could even add filters to it. And the good part is that if you would point an alias to an index, and you would, when you create the index, you connect with, for instance, a timestamp on it, then when you do need to change your mapping, or when you do need to change the amount of shards, you can create a new index, re-index all the documents in the new index, and the moment you're done, you switch the alias from the old to the new index, and your application just keeps running. It doesn't know anything about the change that you make, so always use aliases. Well, what's up with time-based indexes? So a time-based index is used a lot when you use, for instance, Logstash or Beats or whatever, where you could create an index per day or per week, per month, depending on the amount of data that you shoot in. A good advantage of that is that you have the option to change things in between. If you would create a new index every day, you every day have the chance to change your mapping, to change the amount of shards. So if you have a logging set up and suddenly you start logging a lot more, or maybe your website becomes popular and you feel that 1 shard or 2 shards is not enough anymore, then for the next day you could choose 3. Well, how does that work? That works with index templates. So you store an index template in Elasticsearch, and then when you create an index, it checks if there's a template for that index. So you don't have to provide all the information anymore when you create the index. It will actually check if there's a template, and if there's a template, it will use everything in the template to create your index. Okay, design your mapping. So, who still believes Elasticsearch is schemaless? Who thinks Elasticsearch uses a schema then? Still no arms. Damn, you're a tough crowd. It's like 3 o'clock, everybody's tired. So, okay, there's always a mapping in Elasticsearch. The question is, do you create it, or does Elasticsearch create it for you? And that's what we're going to talk about as well. So the default is dynamic mapping. So Elasticsearch, when you insert data into it, it will try to guess what the data is. If it's a string, if it's a date or a number, and then it will create a mapping for you. Sometimes it's just wrong, and sometimes it just doesn't know how to do it. With dates, for instance, if you're sending the milliseconds, which is a long, it will take it as a long. But you can still say it's a date, and then it will understand that it's a date, and it will convert the actual milliseconds into a date. But then you have to specify the mapping. The same is for geopoints. Geopoints are very important, but if you would do a location with longitude, latitude in there, for instance, it will map them to 2 doubles. It will not make a location, a geopoint out of it. So you have to do that yourself. And the same is valid for instance, if you want a double. If you have a money, an amount, and your first amount that you send in doesn't have a digit in it, it just is 5 or 10, then it will make it a long. The next one that you send in would actually be a double, and then you have a problem. So it's very good to be concrete in your mapping and just to be very specific in what you want in there. If you're really up for like mapping everything yourself, you can even switch off the dynamic mapping. And I sometimes do this just to be sure that I don't get surprises, and this would be the way to do it. You can just send it to your Elasticsearch cluster and your dynamic mapping would be switched off completely. What's with a mapping? A mapping is persistent, you cannot change it. Just like with the shards. So if you make a field of a certain type, then you cannot change it anymore. The moment you create an index and you put a mapping in there, you can add new fields. That is possible, but you cannot change them. Well, this is another example of creating an index. In this case, I create a conferences index. And there's something going on here that's very important as well. And that's what's called a multi-field. So what you would do here is, in this case, there's a field called name. And is of type string. And I use the standard analyzer. So the standard way of indexing it. But there's another part here which says fields, and then there's a name, in this case role, because it's sort of a default way of naming it, but you can name it anything you want. And then there's again a type string, but now it's index not analyzed. So in the document that I send in just one field, but in the result I can use it in two different ways. I can use it in an analyzed way, so what that means we get back later on, but I can also do it in a not analyzed way. So I can use it 2 times, and I would use it by calling this name.role. Well, we'll see in later examples, we see how this is used, but it's a very important feature that you need to take care of as well. And if you use Logstash, for instance, Logstash uses a lot of index templates that we mentioned before, and they, for every string field that you insert, they do this trick. So all the strings that you insert using Logstash, if you use the default way of doing it, they will be indexed with a standard analyzer, but also not indexed. And we later on get back why that's important. So what does an analyzer do? Well, an analyzer creates terms out of your data. And the terms are the ones that you're actually looking for when you do full text search. It has 3 main components. It has the character filter, and a character filter can replace stuff. It could be used to take out HTML tags, for instance, and in this case you could also replace an ampersand with the word and if you want to. And then there's the tokenizer, and the tokenizer takes long strings or long sentences or types of text, and it makes terms out of it. It could do it on white space, it can do regular expressions, it can use n-grams, it can use a lot. But it, in the end, is what makes a sentence into terms. And then there's filters, and filters, they can act on your terms, they can change them, or they can create additional terms. So they can also, again, do some nifty stuff with synonyms to add new terms. If you have a word that you want to add, if you have technology and tools, for instance, what you could do that every time the word tools is added to the index, that you also add technology, for instance. Or with Elasticsearch, if Elasticsearch is added, that you add elastic because they changed the name. But that's something that you could do in a filter. And another filter is, for instance, ASCII folding, which would map the strange characters into the normal ASCII characters, and maybe language-specific things like stemming and the more interesting stuff. That's what you do with the analyzer. And it's really important that you think about this analyzer, because this is what enables a lot of very specific features in Elasticsearch. You can make them custom, so you can combine your own tokenizers and filters. You could even write your own tokenizers, but I've never found that to be necessary with all the ones that are out there as well. Well, like we mentioned before, use the multi-field approach. So if you're not really sure, if you want the ASCII folding, for instance, to remove the changed characters, just add an additional field. Use the multi-field to do one field with ASCII folding and then one field without the ASCII folding. And what you can then do when you do a search is, if people then type a word with a strange ASCII character in there, and you have an actual sentence with that character, then you want it to be found. But if you would use the ASCII filter in there, then it doesn't matter whether it's in there or not anymore. So always find the approach that you would during indexing. Don't just filter one thing, just do them both. And very important, do not analyze if you don't need it, because it takes CPU. So if you're sure that a field is only going to be used, for instance, for aggregations or filtering, then you most likely don't want to analyze that field. Okay, let's move on to indexing documents. How can we improve the speed during indexing? Before we can actually tell more about how to improve it, we need to understand a little bit what happens during indexing. So there's a number of components that are important during indexing a document in Elasticsearch. One of them is the translog, and we'll get back to what it is. Then there's Lucene, the memory buffer, and in memory. So let's see what happens when we insert a document into the index using the index API. What it then does, it sends that document to the in-memory buffer of Lucene. So Lucene receives it, and it doesn't do anything with it yet. It just keeps it in the buffer. And you also send it to the translog. Why is that? Well, because Lucene only has that document in memory. The moment that it would fail, your process would crash, you would actually have sent back to the client like, hey, I received your document, and then it would be gone. And that's where the translog kicks in. So the translog is something from Elasticsearch, and what it there does, it writes the document to disk. And then if it's written to disk, it will send back to the client like, yeah, I received your document. And now when it would crash, then Lucene would build up everything from disk, but it would also check the translog and see that there are still documents in there, and it would replay the translog in Lucene, and you would be back in the same state as you were before the crash. But it's still in memory, so I cannot search on it. Well, that's stupid because we want to search. So what happens? By default, every second, a refresh. And what a refresh does, it takes all the documents from the memory buffer and it would store it into a segment. Well, we've seen the segments before. It would create a segment, but the segment would only be in memory in the beginning. So it's still in the translog because it could still fail. But now it's searchable. So if we would now send in a query, then at least we could find this document. And then the next step is adding more documents. And the next step is a flush. And with a flush, we do a Lucene commit. And that would mean that we take all the segments that are in the memory and we would actually write them to disk. And now we create a new translog because now we know the files are in disk. And we can remove the old translog. So how could you use this to optimize during indexing? Because this refreshing is, well, it's already expensive because it has to create the segments. But the flush is even more expensive because it sends it to disk. But if you know that you're not going to search during indexing, because you really want to have the most optimal performance, then you could switch it off completely. That's what I'm doing here. I set it to -1, and now there's no refresh going to take place. So it's only going to be flushed the moment the translog is full. Because that's also a mechanism, if the translog is full in a certain size, then it would flush it as well. And there can be situations in between, where you might want to be able to query, but maybe not every second that every document needs to be available. Sometimes it's like 10 or 30 seconds would be enough. So then you can change it to another interval. And that could be quite a big performance increase. Another one is if you're really going for a lot of indexing speeds and you just want to send in all your data, then switch off replicas. Because if you have a 3-node cluster, for instance, and you have 3 shards, and you would have 1 replica, that would mean that the replicas would also index the documents. So not only the primary shard would index the document, also the replica would index the document. And then your nodes have to do double the work. And it's a lot cheaper to switch off replicas, index all your documents, and then when you're done, switch them back on. And then they send over the binary files. So this is a lot faster. So this is also something that you need to think about when you're doing like maybe your initial index. Well, and then a very important one when you really want to go for a higher speed during indexing is use the bulk. I mean, most of the language drivers have a utility for bulk, but also with curl you can do easily bulk requests. Bulk means just send in a lot of documents at the same time. And it has a lot less memory overhead, a lot less network overhead. There is one thing that you need to take care of. That is if you have a 3-node cluster and you're not using Java, then you have to do the round-robin stuff yourself. So you have to switch between the nodes, because if you would send all requests to the same node, then that node would have to pull all the bulk requests in memory, and then you could overflood one node. So make sure that if you do, for instance, with PHP or curl, that you would go over all the nodes to do the bulk requests. Okay, how to make queries faster. This is the match all query, very basic. I'm going a little bit faster in this area because I think we covered this as well. This is an example of doing a query. I have a few indexes in here, the playground index with 2 shards and 2 replicas. What would happen if you would send a query to that index? It would actually go, you would send it to node 1. Node 2 would know that there is another shard living somewhere. Or node 1 would know that as well, so it would send a request to node 2 like, hey, give me your data as well. And what it could also have done is go to node 3, because the replica of shard 2 is on node 3. So it could choose between those. In the other index is slightly different. This is a time-based index. It's actually 3 indexes now. But you see that the idea is the same. It's 3 shards. I mean, they're named a little bit different, but now there's 3 indexes with 1 shard, and in the other situation there was 1 index with 2 shards. But the idea is the same. If you would send a query here, it would do the exact same thing. Because now I do a query to logs minus star, so I would actually query all the logs indexes, and not just one. And then it would still have to collect all the data. Well, this is another query that you do in the URL, but let's focus a little bit on this one. This is the request body query, a very basic query, Boolean query with a must in there, and 2 match queries. So it will actually query in 2 fields at the same time, and they both must match. And then there will be a hit. In this case, I'll search for the city Amsterdam in the venue, and I search for the term elasticsearch in description. Now, how can we make this query faster? What's the difference in this one and the other one? Well, that's this part. So what happens now is we don't do a match query anymore, we do a filter. Well, what's the difference? Check this one as well. We now have Amsterdam with a capital A. So we know that it's a bit different because the term that's indexed in the raw field was not analyzed. And the original document contains Amsterdam with a capital A, so it wasn't taken out by the lowercase filter like it was in the field that was analyzed. So we have to change it a little bit. But why is this important? That has to do with the query context and the filter context. So let's zoom a little bit out it. The query context is about how well a document matches. So it takes algorithms into account to calculate a score. And the filter context just says it's a match or it's not a match. So that's easier. Query context calculates the score, filter context true false. The big difference there is that the query context is not cacheable. Because it calculates a score, there's too many things that can depend on it. And with the filter context, it's just true or false. And it will remain true or false for that input. So it could easily cache it, and that would be an enormous performance increase. So, if possible, use the query context. And then don't calculate the score. Of course, combine that, like in the query that we did here, where we have the bool query, which is a query context. So there a score is calculated, but for the city Amsterdam, because I just want all the conferences in Amsterdam, there's no score calculated. Another important thing is don't ask for hits if you don't need them. So by default, Elasticsearch, if you don't specify anything, it will return 2 hits. But if you're doing, for instance, aggregations, you don't need hits. So set the size to 0. And another thing that you could do is if the document becomes big, then getting the document over the network could also be a problem. I mean, I had a customer with documents of around 2 MB. And then if you would return like 10 documents, and he was just reading the title. Well, then there is a structure in here that you can filter on the fields that you would actually return. And in this case, I would return all the fields in the venue and the group name and the name. That would be with the source filtering in there. Well, and then if you still want to learn more about it, what you could do is use the profile API. The profile API can help you to see which parts of your query are actually slow. Well, to prove that, let's try a query that I have prepared. Let's see where it is. Well, let's take this one and just add it. So in here you see the hits. And now what we can do is add the profile. And then we take away the hits. And then we see here that, for instance, the top query, the total query took around well, 0.4 milliseconds, which is quite low, but I think there's just 12 documents in here, so it's quite fast. And you can also see that the subqueries in here, how fast they are. So in this case, it's 0.9 and 0.4. So use this to your advantage if you have problems in your performance. I need to speed up a bit, I see. Well, why not use the analyzed fields? Aggregations. This is an aggregation query. Again, the role, and this would be the response, so buckets. Buckets, in this case, 8 events in Amsterdam, 1 in Ede. This is, of course, what we like, because we like Kibana, and now we see red dots. Sort of. You see the red dots if you look good. Really, there are 4 red dots in Amsterdam. And, but a problem with aggregations is that they cannot use the inverted index. And the inverted index is what's used for the search. Well, then we introduce doc values. And doc values are the reason why it's very important to give your operating system a lot of memory too, because doc values are stored on disk, so they're not in the Java memory, not in the heap. And they do that for all the fields except analyzed fields. So that's why aggregations make use of this different kind of store. And if you don't do it on analyzed fields, it would use something else. It would use field data, and field data is in the heap. And this is one of the things that you want to track in your monitoring, because if you don't, if you do this on 2 big fields, then the field data would increase, and then that would be again a reason why you could go out of memory. So let's quickly go into monitoring. This is the health endpoint. There's a lot of endpoints about monitoring. In this case, my cluster is yellow. I have 16 unassigned shards. There is another way of going in a little bit deeper where you would put the level on top. So in this case, I would say indices. And now I see that for this specific index, this is also yellow. And I see that the number of replicas is 1, but I have a 1-node cluster, which is my laptop. So it will not appoint the 5 replica shards that it would like to appoint. Okay. Yeah, this one is important as well. You have the nodes.stats. And the nodes.stats give you a lot of information about your node, about your indices, field data, filter cache. These are the ones that we talked about before. Do track the evictions here. So if you see in the JSON output that you get here, you see evictions, then you most likely have too little data. The OS is kind of clear. Process, file descriptors, because Lucene is file descriptor heavy. JVM, garbage collection, especially monitor the old space. The moment that in your old space you have a problem and the time to do garbage collection there takes too long of a time, you could get stop the world in your JVM, and then your cluster thinks like, hey, this node is gone. So if you have suddenly nodes that just drop out of your cluster, start looking at your garbage collection. Thread pools, again, mind the rejected. So if there is something there, then you have a problem. And the file disk. Well, and then there's the cut API, but I'm almost out of time. So I'll do this very fast. Cut API is ideal. Who doesn't know the cut API? One hand. There's a cut API that you can use a lot on the command line. So the JSON is very good in parsing automatically, but the cut API is good if you're just on the server and you want to see as an operator what's happening. Then there's a cut API, type in _cut/help, and you will find all the options that are available. But this is, of course, the easiest way. Just use Marvel. I think a big advantage of Marvel is that you have history. If you don't have, if you just use all the other endpoints, you just have the current state, which is different. So you would like to have the history as well. You could click and do all the stuff. So install it, see if it's good for you, because it will help you in case you have a real issue. I'm almost there. Logging. The cool part about logging is that you can actually change it on the fly. So if you're coming from Java and you have to do log4j and you have to restart and all those kind of things, there's no way in Elasticsearch you have to do this, because you can just dynamically change the level of logging by just giving this command. And a very interesting other thing that you can do is there's a thing called slow log. And what slow log does, it would log the actual query that's taking too much time. And you can configure yourself how much that time is. So sometimes when you just want to learn something, you can just say it like 0.1 millisecond, and then all the queries that you do are logged. Then you at least can see what's happening. I wouldn't do it in production, by the way, because it's kind of big. And this is an example of what it would look like. And you could actually see here in the source the complete query that was executed. So it's good to also, if you see that you have a problem, then you can just track which queries are causing the problem. That's it. I think I don't have time for questions anymore. So if you have a question, just come to the site and we can walk there and I can answer it happily.